Okay, good day, everyone. I'll be doing this video, okay, for the course corporate finance, okay, like basic undergraduate course corporate finance at Université Laval. But this video on the time value of money is good for anyone who was confronted with problem involving time value and money, meaning everybody on earth. Almost everybody on it. So time has value. Okay, first. So waiting to consume usually generates less utility than consuming immediately, which means that to convince someone to lend money to someone else, the borrower has to compensate the lender for delaying consumption. Similarly, when you look at an amount of money to be received in the future, you have to discount it over the number of periods before you receive this amount of money. So in this chapter, we will be seeing future and present values of a lump sum payment, a one-time investment, as well as annuities, perpetuities, and growing annuities. So future value. Future value refers to the amount of money an investment would grow to over some length of time at a given rate of interest. So this depends on the length of time, the size of the interest rate, and the number of periods during which interest is calculated. Okay. For example, first example, investing over one period. If $100 are invested in an account paying 10% in interest per year, after 1 year, the investment will be worth 100 plus 10% times 100, which means $100 plus $10, $110, right? At time zero, $100 are invested at the rate of 10% per annum or per period. At time one, after one round of interest compounding, the initial $100 will have grown to 10 plus to 100 plus 100 times 10%, 110. Suppose now money is invested for more than one period. So if $100 are invested in an account paying 10% interest per period, after one period, the investment is worth 110. After two periods, assuming the interest payment remains in the account, the total value of the account would be 110 plus 10% of 110. So 1.1 times 110, so 1.1 squared, the initial investment at time zero, which is 100, and this gives 121. So at time zero, $100 are invested at the rate of 10% per period. After two periods, if the 10% received during the first period remains in the account, so the account will be worth $121 after two periods. Good. So 100 times 1 plus 10% to the power 2, the number of periods. If we decompose 121, what do we obtain? So 121 is made of 100, the initial capital, 20, which is the simple interest. So 121 is the result of having invested over two periods. Over two periods, we have collected 2 times the 10% interest rate on the capital. 10% of 100 is 10. 2 times 10 is equal to 20. So 20 is simple interest. And 1, which is 10% times 10% times 100, is interest on interest, compound interest. If we look at what happens after 3 periods, after 3 periods, the $121 that we have after 2 periods R multiplied by 1 plus the interest rate, and this gives $131.1. So at time 3, if $100 are invested over 3 periods at an interest rate of 10% per period, the account is worth $133.1 after 3 periods. Decomposing this $131, what do we have? So we still have, like, the first $100 are the initial capital. 30 is the simple interest. So 10% times 100 times 3 is the simple interest that has been collected over the 3 periods, and 3.1 is the accumulation of interest payments over time. So that's the interest that the first $10 of interest has received in periods 2 and 3, and it's also the interest on the second $10 received in period 2 during the 3rd period. So 3.1 is interest on interest. Oh, good. So more generally, we have this. So if C dollars are invested over T periods at an interest rate R, at the end of the T periods, the value of the account is C times 1 plus the interest rate to the power T, which gives capital plus simple interest, and the balance is compound interest. So when we want to calculate compound interest out of the finishing value of an account, so we take the total value of the account, capital plus total interest, we subtract capital and subtract simple interest, and that gives compound interest, interest on interest. Compound interest can be significant over the long run. So eventually compound interest becomes larger than simple interest. So if $100 are invested over T years at 10% interest rate, compounded annually, after 5 years, the account is worth $161.05, which is $100 in capital, $50 in simple interest, and $11 of interest over interest. After 15 years, the account is worth $417.72, which is the $100 in capital, $150 of simple interest, okay, 15 times 10, plus 167 of interest on interest. So at this point, compound interest is larger than simple interest. After how many years is compound interest greater than simple interest? Well, if we make the calculation, so compound interest is equal to total value minus capital minus simple interest. So we are looking for the time t where compound interest is larger than simple interest. C times R times t is simple interest after t periods. So if we rearrange the equation, we obtain this. So 1 plus r to the power t minus 2 times r times t greater or equal to 1. So we would have to solve this equation numerically, but this is how we would find the time period at which compound interest outweighs simple interest. Okay, throughout this chapter, interest rate, discount rate, and time value of money, all the same. Good. Present value. So we have just seen future value. So future value is capital plus accumulation of interest over time. Present value is how we would value today a payment to be received in the future. Okay, similarly, the present value is the amount that would have to be invested today at the actual discount rate in order to withdraw a specific amount in the future. And as future value, so present value depends on the interest rate, depends on the number of periods and the number of times the interest rate is calculated from here until the moment where the amount of money will be collected. All good? Okay, present value of a future payment is obtained by discounting the future payment, and the future value of a present payment is obtained by compounding the present payment. Discounting is dividing by 1 plus r to the power t. Compounding is multiplying by 1 plus r to the power t. So discounting, dividing, compounding, multiplying. What is the present value of a payment of $100 expected in period 3 if the appropriate discount rate per period is 10%? First, let's discount it to period 1, to period 2. So the value of $100 to be received in period 3 when we are standing in period 2 is represented here by P2. Okay, P2 would be the price, the price at time 2 of $100 to be received at time 3. So between time 2 and time 3, there's a single period, which means if P2 is what would have to be invested over one period to collect $100 at the next period, well, P2 should be equal to $100 divided by 1 plus 10%. Okay, here. So what's the relationship between P2 and 100? So if P2 is the value at time 2 of 100 to be received at time 3, P2 times 1 plus 10% is equal to 100, which means P2 is equal to 100 divided by 1 plus 10%. So if P2 is equal to 100 divided by 1.1, P2 is equal to 90.91. So the present value of $100 to be received at time 3 when we are sitting at time 2 is 90.91. Now, if we go back one more period, so what is the value of $100 to be received at time 3 when we are standing at time 1? So time 1 is one period before time 2. So that means it's the discounted value of 90.91 over one period. So if the price of $100 to be received at time 3 when we are standing in period 1 is represented by P1, well, P1 is what would have to be invested over one period to obtain 90.91 to obtain P2. So P1 times 1 plus 10% would have to be equal to P2, which is 90.91, meaning that P1 is 90.91 divided by 1.1. So 90.91 divided by 9.1, 90.91 divided by 90.91 itself is 100 divided by 1.1. So P1 is 100 divided by 1.1 to the power 2. So 1 is 2 periods before 3. So what do we receive at time 3? 100. So what is the value of 100 2 periods earlier? So 100 divided by 1.1 to the power 2. So 82.64. And now, if we go back one more period, we will arrive at time 0. So standing at time 0, what is the present value of $100 to be received at time 3, well, it has to be equal to 82.64 discounted over 1 period, because P0 is the amount we need to invest at time 0 to obtain 82.64 1 period later. So if we decompose this equation, so P0 is 82.64 divided by 1.1. It's 82.64 over 1.1. 82.64 is equal to 90.91 divided by 1.1. Okay, and 90.91 divided by 90.91 itself is equal to 100 divided by 1.1, meaning that P0 is equal to 100 divided by 1.1 to the power 3. So what is the present value at time 0 of $100 to be received at time 3 when the discount rate is 10%? The present value of $100 is equal to 100 divided by 1 plus 10% to the power 3, 75.13. So more generally, the present value of a cash flow C to be received in T periods when the interest rate per period is R is given by C divided by 1 plus R to the power T. So P would correspond to the amount that would have to be invested today over T periods at the rate R to obtain a cash flow C to be able to withdraw C dollars after T periods.